Hi again, my coronavirus sequestered friends. On 674, I had a request for a couple help for a couple questions. The first one was number 17, and it says the secant of 3 theta is equal to -1 across the domain -2 pi to 0. And really, these seem harder than they are. They're and you're going to ask, if you were in the room, why would we do this? Well, you wouldn't. But we're just learning how the trig functions interact with themselves and the other trig functions. So really, you're just practicing your manipulation skills for trigonometry, because when you get to calculus, the more you can adapt a trigonometric problem, the easier it's going to be to do the calculus on it, because calculus can either be extremely easy or terribly complicated. And if you can turn a terribly complicated equation into something easier, then you're way better off. So really, we're just practicing skills of manipulating trig. So what is this asking? Well, it's saying if we look across the domain from -2 pi to 0, so that means my angle theta is somewhere in that window. Could be in any quadrant, but it's a reverse rotation. Anything within one reverse rotation of the standard position. And we want to know where the secant of 3 theta is equal to -1. Well, secant is never fun to work with. So I know that the secant of theta is 1 over the cosine of theta. So I'm just going to flip it upside down and say 1 over the secant is equal to the cosine, which means I can take secant of 3 theta is equal to -1 over 1 and flip it upside down and say the cosine of 3 theta is equal to 1 over -1, which happens just to be -1. So I'm going to solve for the cosine because it's easier for me to think about. Okay, so my domain has to be inside that window. Okay, and I want to know when is the cosine of an angle that is 3 times bigger than the angle given in the domain is equal to -1. Well, where is the cosine equal to -1? The only time, so cosine of theta is equal to x in the unit circle. The only time that the cosine is equal to -1 is right here at -pi or 3 pi or 5 pi, right? There are an infinite number of those. So if I take an angle inside that domain from -2 pi to 0 and I triple it, when will that angle land at that -pi or 3 pi position? So what I'm asking is what angle multiplied by 3 will give me a position that's in the same place as pi radians. That's basically what that's asking. So how many angles are there in one negative rotation of the unit circle that I can triple, and then those answers will land in that position of -pi or 3 pi? Okay. Well, the obvious one for me is going to be, that's a bad spot, is going to be -pi over 3. So -pi over 3 fits inside the correct window, and when I triple it, I get -3 pi over 3, which is equal to -pi, and this lands here. Okay, now let me say something that's important. Okay, this designation deals with the angle that I chose. It does not deal with the resulting angle after I triple it. So I chose negative pi over 3. That was my theta. I tripled it, and it landed in the spot that I needed to create the negative 1. So this domain deals with the original angle, not the resulting angle, not the tripled angle. Well, are there any more? Well, yes, but I've made a terrible mess of this. So I know that negative pi over 3 is one of them. Okay, so let's just try another one and see what happens. Let's try negative pi over 2. So that angle is right here. If I triple that, then I get negative 3 pi over 2. And where does that land? Well, negative 3 pi over 2 is right there. Does this point satisfy that number? No. The cosine at that point is 0, so pi over 2 did not work. So let's try. Let's see what happens when I do negative 2 pi over 3. So I triple that, and I get negative 6 pi over 3, which is negative 2 pi. Where does negative 2 pi land? Well, negative 2 pi is right here. Is the cosine of that position equal to negative 1? No. So negative 2 pi over 3 did not work. Okay. Hopefully you're kind of seeing how this works out. Should I try negative 3 pi over 4? No, because I'm going to be multiplying by 3, and my answers need to end here, and those are all whole numbers. In fact, they're all odd whole numbers. So I want to pick angles that I can triple, and I get a result, and they're negative whole numbers, or they're not whole numbers, they're negatives, but they are odd numbers. So I want negative pi, or negative 3 pi, or negative 5 pi, or negative 7 pi. Those are the numbers that I want to get when I triple. Okay, so I could keep going through and guessing more and more angles, but I certainly don't want to put a 4 in the denominator because that's never going to cancel the 3. So I could keep going around this circle and guessing angles and angles and angles and angles and angles until I get here and then I stop. But why don't I reverse engineer this? That's pretty simple. I know, oops, what did I do? I know that those are the numbers I want right here. So why don't I start with the answers and then just go backwards? So the only time that the secant is going to equal negative 1 is when the rotation stops on this point. Well, because I'm rotating backwards, here are all of those points. So I'll just divide them each by 3. So divide the first one by 3 and I get negative pi over 3. But I have to ask, does this fit in that window? Yes. Negative pi over 3 is in quadrant 4. That is the first quadrant when you spin backwards. Okay, the next one, divided by 3 and I get negative 3 pi over 3, which is negative pi. Does that land in that window? Yes. Okay, then 5, negative 5 pi over 3. Does that land in that window? Well, 5 pi over 3 is less than 2, so that's going to be right here in quadrant 1. All right, what about 7? Negative 7 pi over 3. Well, negative 7 pi over 3 is a little bit bigger than 2, So that's going to put us in quadrant 4. So this angle does not fit in that domain. So my answers are just these three. Negative pi over 3, negative pi, and negative 5 pi over 3. I hope that helps. I have no idea how I did it in the video, but that's how I did it today. Okay. The next one was number 31. 2 cosine of theta, cosine squared, I believe, minus the cosine of theta is equal to 0. And I want to know, solve from 0 to 2 pi. So I want to know how many times does this function equal 0 over this domain. So that would be 1 rotation. How many times does that particular function equal 0 within 1 rotation from standard position? So I'm going to factor out a cosine, and I get the cosine of theta times 2 cosine of theta minus 1. Well, let's just treat this like a quadratic. X times 2x minus 1. Well, when that equals 0, x is either 0 or x is 1/2. So how many times does the cosine equal 0 or 1/2? Well, cosine of theta is the x value in the unit circle. So to satisfy the 0, we would need to be here or here. So pi over 2 and 3 pi over 2. Okay. And then when does the cosine equal 1/2? Well, cosine is the x value, so that would be at 60 degrees or pi over 3. And then same thing in quadrant 2, except it's negative, so we're not going to count that one. And then when we go to quadrant 3, it's also negative, so we don't count that one. And then again in quadrant 4, and that's 1/3 short of 2, so that would be 5 pi over 3. So the answer is pi over 2, 3 pi over 2, pi over 3, and 5 pi over 3. But why does that work? Well, watch what happens when we plug those in to the original equation. So, watch what happens when we plug in pi over 2. So 2 times the cosine squared of pi over 2 minus the cosine of pi over 2. Well, the cosine of pi over 2 is 0. So we get 2 times 0 squared minus 0 is 0. And the same thing's going to happen when we plug in 5 pi or 3 pi over 2. Okay, let's plug the other one in. So pi over 3. So 2 times the cosine of pi over 3 squared minus the cosine of pi over 3. Well, from the unit circle, the cosine of pi over 3 is 1/2. So I get 2 times 1/2 squared minus 1/2. Well, 1/2 squared is 1/4. So 2 times 1/4 minus 1/2. And you can see I get 1/2 minus 1/2, which is 0. So really all we have is a quadratic equation, 2x squared minus x equals 0. We simplify down, figure out what the roots are, use those roots in the unit circle to find those angles that create the roots. All right. There was one more. 39. So the secant squared of 2 theta minus 4/3 equals 0. That one looks kind of complicated. So Let me take a look at the reference sheet. I didn't do this beforehand, so maybe I'll fall on my face. Okay. So I don't like secants. I prefer cosines. And I'm going to move this to the other side. So the secant squared of 2 theta is equal to 4 over 3. And then I need to decide, am I going to deal with the squared or the 2 theta? It will probably work both ways. Let me just take a look. So secant squared is tangent squared plus 1. That might work. The cosine of 2 theta. Yeah, let's do that. So I'm going to turn this into a cosine problem. So the cosine squared of 2 theta is equal to 3 over 4. I just flipped the whole thing upside down. All right. What should we do now? It's a good question. Cosine squared is 1 minus sine squared. Okay, I think I got it. So there is a cosine of 2 theta. Well, there's several cosine of 2 theta formulas, but none of them have a squared on it. So let's get rid of that squared. We'll just take the square root, and I get the cosine of 2 theta is equal to root 3 over 2. And now there are all sorts of ways you could solve this, but I imagine the way they want you to solve it is just like we did on that first problem. Does it give me a domain? Yeah. So my domain is from 0 to 2 pi. So once again, I want to know if I choose an angle within that domain, how many ways are there to double the angle and perform the cosine such that the answer is root 3 over 2? Well, the cosine is equal to root 3 over 2 in that pi over 3. Nope. I got it backwards. It's the pi over 6 angles in 1 and 4. So those angles are pi over 6, and then the one in quadrant 4 would be 11 pi over 6, and if I kept going, 13 pi over 6, and then that would be 23 pi over 6, and if I kept going, 25 pi over 6, and there are a whole bunch more. Right? So, how many ways are there to take an angle within one rotation and double it and land in one of those places where the cosine is 3 pi over 2? Well, like we learned in the first problem, let's just take our set of possible answers and then do the opposite of what's inside the cosine. So pi over 6 divided by 2 would be pi over 12. Now let's work this through just so you understand how it works. What is the cosine of 2 times pi over 12 equal to? Well, first I have to ask, is this angle inside that window? Yes. Pi over 12 is inside one rotation. What happens when I double it? I get the cosine of pi over 6. Is the cosine of pi over 6 equal to root 3 over 2? Yes. Now I've satisfied both requirements. I found an angle that's in the window, and that angle, when doubled, creates a cosine value that's equal to the number I need. Okay. So let's try the next one. 11 pi over 6. Divide that by 2, and I get 11 pi over 12. Okay, I'm going to stick that in that same problem. The cosine of 2 times 11 pi over 12, is that equal to root 3 over 2? Well, first, is this angle in the appropriate window? Yes, it's less than 1 pi. It's in quadrant 2. When I double it, I get the cosine of 11 pi over 6. Does that equal this number? Yes. So that's another answer. Let's try the next one. 13 pi over 6 divided by 2 is 13 pi over 12. Is this in the window? Yes. When I double it, I get 13 pi over 6, which, taking the cosine, yields root 3 over 2. Okay, try the next one. 23 pi over 12. Is that in the window? Yes. 23 over 12 is just slightly less than 2. When I double it, I get 23 pi over 6, which 23 pi over 6 is going to be 12. Sorry, I'm doing 6. So 6 over 6, 12 over 6, 18 over 6, 23 over 6, right there. The x value is root 3 over 2. Let's try the next one. 25 pi over 6 divided by 2 is 25 pi over 12. Okay, is this in that window? No. 25 over 12 is bigger than 2. Now, this does give me root 3 over 2 when I take the cosine. Well, I double it and then take the cosine. But that number is not in the domain, so that one gets thrown out. So those are the answers to this original problem. Hope that helps. Let me know if you need more.